Hello, my friend. Our today's video is about large language model enabled in context learning for data collection scheduling in UAV assisted sensor network. Compared to existing methods like convex optimization or conventional machine learning, LLM-enabled ICL offer key advantage. Okay, large language model enabled in context learning has some key advantage. It relies on the LLM inference process, eliminating the need for complex model training and fine tuning. For example, using deep reinforcement learning, we have complex model training and fine tuning, but in context learning, eliminate the need for complex model training and fine tuning, which are often bottleneck in machine learning. My name is Yusuf, and I am going to present this video. Okay, here you see the outline, introduction, proposal, overall design, attack model, data communication protocol, jailbreaking attack, proposed algorithm, simulation parameters, and finally result and reference. Introduction. In recent years, the integration of UAV technology into search and rescue operation has revolutionized the field, offering a powerful tool to enhance the efficiency, effectiveness, and safety of rescue mission. Okay, UAV technology has revolutionized the search and rescue operation. A common trend in search and rescue operation is the use of deep reinforcement learning to optimize data collection. Okay, but we have some problem. Deep reinforcement learning method or deep reinforcement learning optimizer have complex model training and fine tuning. They have low sample efficiency and they suffer from simulation to reality gap. Okay. On the other hand, large language models are transformative technology with successful application in education, finance, healthcare, biology, and more. Their potential extend to network management and optimization, particularly through in-context learning, a feature that allow LLM to learn from language-based description. Okay, what is in-context learning? I have recorded a video previously on this subject. You can find in my channel and explain it what is in-context learning. But again, here I repeat, it's a feature that allow large language model to learn from language-based description and demonstration. Okay, learn from language-based description and demonstration. Okay, this benefit makes LLM enabled in context learning a promising approach for simplifying and enhancing network management and optimization tasks. For example, unmanned aerial vehicle can use LLM-enabled ICL to optimize data collection, scheduling, and dynamically adapt to changing environment. However, the use of LLM also introduced vulnerability to jailbreaking attack. What is this jailbreaking attack? Means to manipulate the task description. When you provide data to large language model, you provide a task description. This jailbreaking attack bypass the task description and manipulate the data of the task description to reduce the target performance. Okay, but what is the proposal? Given the challenge and opportunity of large language model, this video investigates ICL-based data collection scheduling scheme. Okay, ICL-based data collection scheduling scheme. Specifically, we conduct ICL to optimize data collection scheduling in UAV-assisted sensor network. Okay, we want to use in context learning to optimize data collection scheduling in UAV assisted sensor network. The UAV interact with the environment to collect outdated sensory data and transmit it to large language model for analysis and decision making. Okay, here you see the overall design. We have a system prompt that defines the role of the UAV as a data collector. We have task description that include the following item: task goal, input data, role and constraint, output, and feedback. Okay, but when I was talking about jailbreaking attack, I mean attacker manipulate this data and force LLM to make wrong decision that decrease the performance. Okay, this is our task description. As you can see here, uh, we feed this task description to the large language model. It make a decision, schedule a sensor, and determine data collection schedule. And finally, we collect feedback from the environment data and pass this data again to the task description. And this loop is repeated. Okay. So let me once again tell you in a nutshell. The UAV interact with the sensor. Okay, it collects the data related to the Q lens and channel condition. After collecting this data, it passes this data to task description. LLM receives this task description and based on this task description, make a decision, data collection scheduling, and this is a loop. Okay, what is the task goal? Optimize data collection scheduling to minimize packet loss. Input data is sensory data, Q lens and channel condition. We have some role and constraint. We specify output that schedule a sensor, and we have the feedback. Okay, this is the overall design of the proposed ICL DC. Okay, here you see in this table a summary of the attack model. What is the attack goal? Degrade the UAV data collection performance by biasing the LLM data collection schedule. Okay, attack method is template completion attack with context based manipulation. And malicious example, crafted prompt that condition the LLM to prioritize compromised grand sensor, and impact is in the increase the packet loss. Okay, here you see in this slide the data communication protocol between UAV sensor and large language model. As you can see, the UAV run the proposed approach, schedule a ground sensor send back data, UAV acknowledge the receipt of these data. Meanwhile, UAV for making decision, pass the collected data by sensor to the large language model, and after getting the result, go for another round. Okay, here you see summary of jailbreaking attack in large language model. What is jailbreaking? Exploiting large language model vulnerability to bypass safety mechanisms and generate unauthorized content. Okay, simply manipulating that task description to increase the performance, to decrease the performance. We have white box attack, black box attack. White box attack introduced here, black box here. We have template compilation attack that manipulate the task description, and our technique is context-based manipulation. Okay, here you see the proposed algorithm. What is input is sensory data, Q length, and channel condition. What is the output of the algorithm? Optimize the data collection schedule. First, UAV collects sensory data on Q length and channel condition, and then large language model process this data and make a decision using in context learning. And finally we have the feedback, and The output is optimized data collection schedule. Okay, here you see simulation parameter. Number of grand sensor is 10. Q length is 40. Number of time step is 20. Epsilon decay. Maximum transmit power 100 milliwatts and maximum battery capacity 50 joule. Okay, here you see the performance. We have the proposed approach that use GPT-4o mini is the blue line, and we have a benchmark maximum channel gain. This benchmark select the grand sensor with best channel condition in comparison to the ICLDC. ICLDC also plus two channel condition. It considers the Q length. You can see that the proposed approach outperforms the maximum channel gain that use GPT-4o mini as a large language model. Also, here you see the performance of the proposed approach with different large language model for O-mini, 3.5 turbo, and O3 mini. As you can see, for O-mini has the best performance. Okay. Thank you very much. The reference is my recently published paper on archive, LLM enabled in context learning for data collection scheduling in UAV assisted sensor network. I strongly recommend you to read this paper. This can be a new direction in UAV communication. Thank you very much. I appreciate to like and subscribe.